Okay, hi and welcome. Today we're going to cover notes 3.4, which is solving multi-step inequalities. The one thing I would like you to know about these is that we're going to treat them the same way as we do equations. So our rules for solving of reverse order of operations, actually before that, order of operations, and doing reverse order of operations in terms of inverse operations all holds true. So if you recall those terms, you're good to go. If you don't, just remember this. However you solve before is exactly how we're going to treat these. There's one small difference, though, that we're going to discuss right now. What is the mean difference between a solution of an equation and an inequality? Well, that's easily put. In an equation, we find one point, some coordinate point that we've been dealing with, an x and a y coordinate point. For an inequality, it's a whole bunch of points. It's many points. Okay? So once we kind of get that concept down, that we're dealing with a lot of different situations, we can say that a solution of an inequality is any number that makes the inequality true, which we just said was many points. So we're definitely looking for one. When we write these solutions, they need to be represented as an inequality. We should never use an equal sign because the equal sign indicates 1 point. And we definitely don't want that to happen. One coordinate point, or one coordinate most often. All right, so let's do a little investigation, see if we can learn. There is one rule that we kind of want to pull out of here that's slightly different from equations to inequalities. And we're going to do, and I kind of done the investigation for you, but what we're going to do is we're going to check one statement here, an inequality statement. We're going to check the fact that 4 is greater than 1. We all know that to be true. We're not too concerned with that. 4 is greater than 1. But what we're going to do is some operations like addition, subtraction, multiplication, and division, and we're going to check to see if that stays true after we try those operations. So this is kind of like an informal proof to see how these operations work, and we might be able to make a rule out of this that we can't see quite yet. Okay, so you can see here I've set up a little table, and we set up the columns of the different operations we're going to check. Starting with, and I've already filled this out, so it might look a little bit confusing, but you can look here. Here's 4. 4 is greater than 1. So now we're going to check addition. I added one more row here because I kind of wanted you to see it. But starting off with the row that we looked at, for positive 1, if we add positive 1 to both sides, we'll see that that stays true. 4 plus 1 is 5. 1 plus 1 is 2. 5 is greater than 2. That's true. We have no trouble there. Then I went back and added a row 2 so you can kind of see it. So if you need to pause the video, go ahead. But what we're seeing here is that positive numbers, if I add 2 to 4, 2 plus 4 is 6. 2 plus 1 is 3. 6 is greater than 3. And we can keep that going. We go 3 and 4 and 5. And we'll see that that's true no matter what as we go up the list here. Okay? So let's take a look at 0. 0 plus 4 is 4. 0 plus 1 is 1. That also holds true. Let's check negative numbers then. We'll just check 1 for now, which is negative 1. So I'm going to take 4 and I'm going to add negative 1. So 4, that should be not 5, that should be 3. I'm not really sure what I was thinking there. So let's go ahead and clean that up. This should be 3. 4 minus 1 is 3. And 1 minus 1 should be 0. Not sure why I wrote that incorrectly, but now we've got it fixed. So it looks to be true for negative numbers as well. 3 is greater than 0, and if we kept going, we would see that that would be true as well. So let's take a look at subtraction. Again, 4 greater than 1, that's our true statement. We know that to be true. So now we're going to start subtracting numbers. So 4 plus a negative 1 gives us 3. And 1 minus 1 gives us 0. So again, 3 is greater than 0. That is true. Okay, so let's add 0 to both sides. Well, it doesn't do, or subtract 0 from both sides. It doesn't do anything. So 4 is still greater than 1. So let's subtract a negative 1. So that's really 4 minus negative 1, or add it together should be 5. I think I was looking at the wrong row of notes when I copied these down because these are wrong. So that should make 5. And that, again, on the other side is going to be 1 minus a negative 1, which makes it positive. So it's going to be 2. So 5 is greater than 2, so that's true as well. So far under addition and subtraction, we see that both of these, we can't seem to find a situation that either of these don't work. So these are both true. So we're not worried about addition and subtraction. So let's check multiplication. Let's hope I got my rows right this time. So going back here, 4 is greater than 1. There's our true statement. So I'm going to start by multiplying 1. 1 times 4 is 4. 1 times 1 is 1. 4 is still greater than 1. Well, what happens when we multiply by 0? 4 times 0 is 0, and 1 times 0 is 0. So we find out that 0 is greater than 0, and that doesn't work. That's actually incorrect. Kind of unidentified. We don't really know what's happening there, so we know that there's an oddity at 0. So we'll leave it at that. We just know that when we multiply by 0, things may get a little weird. Usually when you multiply by 0, things all turn to 0 and things get boring, is really what it comes to. So let's check the next one. Let's multiply by a negative number. So I'm going to take 4 here. I'm going to multiply by negative 1 because that's the row we're in over here. So 4 times negative 1 is negative 4. Okay, I'm going to put my inequality sign in here. And then 1 times negative 1 is negative 1. Let's check that statement. Is negative 4 greater than negative 1? No, it's not. So what we find is quite the opposite. Negative 4 is less than negative 1. We would really kind of have to flip this sign to keep that statement true. So we're kind of deciding our rule here. We can see that there needs to be a flip going on. If we multiply by a negative number, if we did it for negative 2, you would see that that would be true. You can check that on your own. Let's check division as well. So we're going to take 4 greater than 1. There's our true statement. So 4 divided by negative 1 is negative 4. There's our inequality sign. And then 1 divided by negative 1 is also negative 1. And again, we see the exact same thing. And I can tell you to be true for negative 2 and negative 3 and negative 4 and 5 and however many negative numbers you want to divide or multiply by. What we're finding out is that we're going to have to flip that sign to keep this to be true. And that's a rule. Okay, so that was a quick way to get to, if you multiply or divide by a negative number, then you have to flip or reverse that inequality sign, whatever it happens to be. So what we learned was solving these inequalities is the same as solving equations, except for this rule here. If we multiply or divide by. All right, so let's put that into application and try it on a problem. Again, here's a problem done for you. Again, if you want to pause the video and write it down so you have those notes, great, go ahead. I'm going to walk through it real quickly. Just like any other problem that we're solving, if we're trying to find out what this unknown t is, we've got some parentheses. Those come first, right? That would fall under the order of operations. So we distribute this 2 to get rid of these parentheses so we can get to that t. So 2 times t is 2t, times 3 times 2 is 6. Drop down our negative 3t, and we go through the solving process just like we normally do, right? Start by order of operations. We did that, distributing the t. Then we start doing reverse order of operations. Again, inverse operations here, IO, so we can check that off, to get them to the other side of the inequality. What we find out here is this last step is that we divided by a negative. So dividing by or multiplying by a negative means we flip the sign. So when we're all done dividing by this negative 5, you'll notice that we went from a greater than sign to a less than and equal to sign. So that's the only rule that you have to address here. Otherwise, everything's exactly the same. So let's go over here to this one and just see how it works. Again, here's a, our unknown. Let's solve for it. There's no order of operations, no distributive properties or parentheses, so check on that one. So let's go ahead and move this 7. So I'm going to subtract 7 because we're under reverse order of operations, which means addition and subtraction is first. So I'm going to minus 7 from both sides. I'm going to get 6a is greater than 12. And then I'm going to do inverse operations here and divide by 6 on both sides. So this one didn't have a division or a multiplication of a negative. So what we find out is that a is greater than 2. So that means that any value, and if we draw a quick little number line here just to recall, any value that makes this inequality true, because we said it's a whole bunch of numbers, could be represented pretty easily by finding 2. So I'm going to just do a rough sketch. There's 2. And any value that's less than 2, not including, so it's an open circle. So all the values that are on this side will make that statement true. Okay, all the way down to negative infinity. So any of those values are true. And that's what it means, all of these points. Okay, so here's your homework. If you're in the first 3 hours, you'll do this in class. If you are in hours 5 and 6, you will do this at home as part of the video, so you can start it right after this. All right, hopefully that was helpful. If you have any comments, post them in the community, and we'll see you in class.